The year was 1979. Southeast Pennsylvania is home to a small city named Elizabethtown, which was inhabited by nearly 8,000 residents, and another larger city, Harrisburg, which belonged to a much greater 68,000 people. These two towns had something in common. In late March of 1979, due 5 miles west from Elizabethtown and a mere 2 miles south from the edge of Harrisburg, sat an island home to 2 nuclear reactors, one of which was on the verge of a total nuclear meltdown that could have killed millions. These reactors sat just off the shore of Pennsylvania, on an island called, creatively enough, 3 Mile Island, which was located almost perfectly between the 2 banks of the Susquehanna River. It was a quiet morning on March 28th, when, unexpectedly, a relatively small event nearly cascaded into what could have been the worst nuclear disaster in history. The time was roughly 4 a.m. The second reactor of 2 on 3 Mile Island, aptly named Unit 2, suffered a pump failure, which in turn stops the cooling tower from creating steam. For a nuclear reactor to cool, it must use steam, which carries the heat away from the reactor core. However, the problem wasn't with the pump itself. The problem was with a small valve that was used to hold water in the water tank that the pump pulled from. The valve was stuck in an open state, which allowed the water to drain from the tank. In result, the pump had no water to pull from. A first-hand account from one of the engineers stated that the entire control panel was lit up like a Christmas tree. It's now 6 a.m. 2 hours have passed, and the nuclear reactor's temperature was rising fast. Within hours, the core itself had reached dangerously close to meltdown temperature, 4,300 degrees Fahrenheit. To put that into perspective, a reactor will experience total non-negatable meltdown at 4,800 degrees, and a typical operating temperature for a reactor is around 600 degrees. With some quick math, we can see that the reactor was rising in temperature at a rate of 2,150 degrees per hour, leaving only around 15 minutes until complete disaster would strike. It was during this time contaminated water was leaked into the reactor, causing radioactive gases to build in the reactor building. The plant then raised the first ever nuclear disaster warning the United States had ever seen. 20 more minutes pass, and the time is now 6:20 a.m. The engineers at the power plant had finally found the issue that was causing the core not to cool, the stuck valve, and proceeded to force it shut. It is unknown what the temperature was at this time, but the temperatures would not reach total meltdown levels. However, this did not solve the problem. Steam and gases from the extremely hot reactor core blocked the flow of water through the core's cooling system, which in turn kept the temperatures extremely high. A whole day had finally passed, and the time is now 7:30 p.m. Engineers developed a plan to cool the reactor. They planned to push high-pressured water through the valves to combat the negative pressure created by the superheated steam and gases. This plan succeeded and allowed the engineers to restore the main pump that has not been operating since 4 in the morning. Over the course of the next couple of days, engineers had begun piping the radioactive gases to a separate building where they planned to fill decay tanks with the hazardous substance. To push the gases through the pipes, they used compressors. This is where the biggest error lay. The compressor that was being used to transport the gases suffered a leak, and at this point, the gases had finally escaped. Luckily, however, for the gases to fully escape the plant, they had to pass through HEPA filters. HEPA filters remove everything but the noble gases. The aftermath, however, was quite fortunate in terms of public health. Everyone who lay within 5 miles of the reactor, a total of 30,000 people, were monitored closely for 20 years. The findings were that there were no irregularities in these people's health due to the radiation that escaped being so low. In fact, the average amount of radiation each person received was 0.08 millisieverts. By comparison, that's the same amount as a typical chest x-ray. On the other hand, the nuclear reactor, Unit 2, did not fare so well. Just over 50% of the reactor was completely melted down. As a result, Unit 2 would never be used again to produce energy. The widespread view of this event would be the largely negative views towards nuclear energy in America. So, when analyzing the failure of 3 Mile Island, There's no one specific thing to point at. As a matter of fact, there's several things to point at. The first major failure at Unit 2 was the lack of metering systems. There was actually no meter in place to detect the level of the water in the coolant tank. As a result, there was a huge delay between when the operators were able to identify the problem with the stuck valve and when the problem actually occurred. To make matters worse, another major issue faced by the operators at the plant was no emergency training. This is a huge deal. Operators may know how to fix a problem, but they don't know how to react during an emergency scenario. This often results in operators panicking and not knowing how to fix something during a critical time. By comparison, modern-day airline pilots have emergency procedures for everything that could go wrong. You wouldn't want a pilot that didn't know how to deal with an engine failure or a computer failure. And if you want somebody who can fly an aircraft to be competent during an emergency situation, you would want somebody who has the power to control a nuclear bomb to be prepared in an event of an emergency. Airline pilots have to protect hundreds of citizens, whereas power plant operators have to protect a 50-mile radius of life. A 50-mile radius is what is recommended for evacuation protocols. That's the lower southeast quarter of Pennsylvania. And finally, the worst thing that happened in this incident was the officials' response to the public. It was around 7 a.m. that it was first reported that there was an incident at 3 Mile Island Power Plant. The next announcement was made the following morning, leaving people confused and scared. And what was that following announcement, you may be wondering? Well, the NRC had stated publicly that there was nothing to worry about that morning and that the danger had passed. However, despite what the announcement said, officials were actually aware that there were gases that would likely escape the plant. Before long, another announcement was made by the NRC, or the Nuclear Regulatory Commission. They stated that everyone should stay put in their homes. But a meager 2 hours later, they issued another warning, informing pregnant women and children to evacuate the area. The public didn't respond to this well. Everyone was left wondering why only pregnant women and children. Aren't I at risk too? Meanwhile, while all this was happening, a hydrogen bubble was forming in Unit 2. Had it burst, it would have endangered a 20-mile radius affecting 600,000 people. A quote that really captured the moment from a local said, "What to do? Lock up and leave? Wait and hope for the best? Wait to be told to evacuate?" This quote really allows us to see the uncertainty that those in southeast Pennsylvania were feeling. To top it all off, no officials in the area had any mock-up evacuation plans. This to me is likely why they were hesitant to issue evacuation protocols for a large amount of people. However, this isn't how you should treat a human life. To wrap it all up, it was 7 days that citizens had to wait in this area before they were finally told that the hydrogen bubble would not burst. There was now a great mistrust in the US for nuclear power, and many say that the official response during this time was much worse than the event itself. So, according to the NSPE Code of Conduct, National Society of Professional Engineers, we can see that there are many violations of this code. First, Section 2.3. Engineers shall issue public statements only in an objective and truthful manner. This code was breached as part of the response to the public when officials had stated that there was no danger, when they were aware the problem was very much still relevant. A direct example of this is seen with Jack Herbine, an engineer for Unit 2. He gave a press conference stating that the contamination had been under control, and that though there was a problem, it was contained. This was later found out to be a complete lie. Next, Section 2.2. Engineers shall perform services only on areas of their competence. This clause was being consistently breached due to the lack of training for any emergency scenarios. As a result, none of the engineers were competent to handle a disaster situation. This leads clearly into the final and possible most important clause being broken. Section 2.1. Engineers shall hold paramount the safety, health, and welfare of the public. The public was put at great risk by a combination of events. First, the misreporting done by Unit 2 representatives. Second, the failure to implement all the proper meters and sensors for critical parts of the plant. Third, the lack of emergency training significantly increased the risk for those who live in the area. And finally, the lack of having an evacuation plan in case of an emergency. Running this event through the ethics filter, we will analyze specifically the response. This is, without a doubt, the most ethically flawed portion. Our first checkpoint is the right to life. So, does the response violate one's right to life? No. No one was injured or had increased rates of cancer, according to the study mentioned earlier. Though there were risks, that is not a violation to the right of life. Yet, the security of one's person was in clear violation. The public was lied to about the danger and risks involved in not leaving. Even the officials who knew that there was more risk than what was let on only told kids and pregnant women to evacuate, basically telling the public the risk is present. So yes, the security of one's person was in danger due to the risk of a greater catastrophe being covered up. Now, even though this event has been proven to be ethically flawed due to a breach in the security of one's person, we will also take a look at the Kantian principle of respect. What is our red flag? Deception. Let's take a closer look. To break it down into 4 parts, we have the exploiter. This was in the form of information manipulation as it was presented to the public. Next, the exploitee was the public who lived around 3 Mile Island, whose lives were put at stake. So, what was the exploiter after? As I briefly mentioned earlier, I believe that the engineers didn't want to cause a scene and tarnish the reputation of the company. Additionally, officials didn't want to cause a panic because they knew there was no solid evacuation plan. Finally, the means which the exploiter used to exploit the exploitee was deception. The officials were only presenting half-truths to the public, such as, there was a problem, but there is no risk. Therefore, this is a clear violation of the Kantian principle of respect. Finally, let's discuss what could have improved the outcome of this event. The first incentive would be to designate a time each month to emergency training and planning with other facilities across the globe. They should analyze past incidents and predict future ones. At the end of each training session, a test should be given running an engineer through a specific scenario. If the engineer fails the test, they should be taken off the job until they can retake it and fully pass it. The second important incentive would be a full inspection of a plant system to test metering systems and automated functions. In order to prevent future disasters, plants must be held to a standard, and if they fall behind that standard, the plant must close down until it is up to spec. To end this, I want to leave you with a press conference that was held 48 hours after the incident that could shed some light on why there was so much panic during this situation.
I think it's the same location as that we normally were getting
So there was no problem in the reactor room that you know of?
No, there was no problem in the reactor room.
Well, you said that water was being transferred from one tank to another tank.
From one area to another area.
What water are you talking about?
The coolant water, the high-level coolant water that contains the xenon.
Tom, was that from one area within the auxiliary building to another?
I'm sorry, I don't know.
Was this primary water?
Primary water.
You don't know where it was being transferred from or to? Is that what you just said?
That's right. I don't right now. Our nuclear engineer who does is not.